Ever since humanity first looked up at the night sky, we've been driven by a profound curiosity. We've asked ourselves, where did all of this come from? How did the universe begin? And are we alone in this vast cosmic ocean? For centuries, these questions remained in the realm of philosophy and imagination. But today, we have a new eye on the cosmos, a technological marvel that is turning these age-old questions into fields of scientific discovery. I'm talking about the James Webb Space Telescope, a time machine that's letting us peer back to the very dawn of creation. Launched on Christmas Day, 2021, the James Webb Space Telescope, or JWST, is arguably the most advanced and complex scientific instrument ever built. It's the result of decades of brilliant engineering, international collaboration, and a relentless human desire to know the unknown. Built by NASA with major contributions from the European and Canadian space agencies, Webb is often called the successor to the Hubble Space Telescope. But it's so much more than that. While Hubble showed us the beauty of the universe, Webb is designed to reveal its origins, looking deeper into space and further back in time than ever before. To understand what makes Webb so powerful, let's look at its incredible design. The first thing you'll notice is its stunning primary mirror. Spanning 6.5 meters across, it's nearly 3 times the size of Hubble's. This mirror is a work of art, composed of 18 hexagonal segments made of beryllium and coated in a microscopically thin layer of pure gold. Why gold? Because it's exceptionally good at reflecting infrared light, which is the key to Webb's vision. These segments fit together like a perfect honeycomb, creating an enormous light-gathering bucket. This massive size allows Webb to capture the faint, ancient light from the most distant objects in the universe. But collecting that faint light is only half the battle. To see in the infrared, the telescope has to be incredibly cold. Any heat from the telescope itself would create its own infrared glow, blinding it to the faint signals from distant galaxies. This is where Webb's second most iconic feature comes in, its massive, 5-layer sunshield. Unfurled in space, this shield is the size of a tennis court. Each layer is thinner than a human hair and is made of a special material called capton. This shield acts like a giant parasol, blocking heat and light from the sun, earth, and moon. It keeps the telescope's instruments chilled to an incredible -233 degrees Celsius. That's just a few tens of degrees above absolute zero. And unlike Hubble, which orbits just a few hundred kilometers above Earth, Webb is positioned much, much farther away. It's stationed at a special gravitational balance point known as the second Lagrange point, or L2, about 1.5 million kilometers from us. This distant stable location helps keep the telescope cold and provides an unobstructed view of the cosmos, allowing it to stare at a single patch of sky for days on end to collect the faintest whispers of light from the dawn of time. So, with this incredible technology, what is Webb trying to find? Its scientific goals are nothing short of revolutionary. One of its primary missions is to look for the first light in the universe. Scientists want to see the very first stars and galaxies that formed just a couple of 100 million years after the Big Bang. Think about that for a second. The light from these objects has been traveling for over 13.5 billion years to reach us. By capturing it, Webb is literally looking back in time, helping us piece together the story of how our cosmic home came to be. Another thrilling objective is the study of exoplanets, planets orbiting other stars. For thousands of years, we've wondered if other worlds like our own exist. Webb is our first real tool to investigate that question. It can analyze the light that passes through the atmospheres of these distant worlds. By looking at the spectrum of that light, scientists can identify the chemical fingerprints of different gases, like water vapor, carbon dioxide, and methane. These are the building blocks of life as we know it. Finding them on a rocky, Earth-sized planet in the habitable zone of its star would be one of the most profound discoveries in human history. Webb is also giving us an unprecedented look into stellar nurseries, the beautiful, chaotic clouds of gas and dust where new stars and planetary systems are born. Visible light telescopes like Hubble can't see inside these dense clouds. But Webb's infrared vision cuts right through the dust, revealing the fiery young stars and protoplanetary disks within. We're getting to watch star and planet formation as it happens, learning more about how our own solar system might have formed billions of years ago. It's like having a front-row seat to the creation of new worlds. Even in its first couple of years of operation, Webb has completely shattered our expectations. It has already delivered the deepest and sharpest infrared images of the distant universe ever taken, revealing thousands of ancient galaxies in a tiny speck of sky. These images are filled with galaxies that existed over 13 billion years ago, some of which are brighter and more developed than our theories predicted. Webb is not just confirming what we thought we knew, it's challenging our models and forcing us to rethink the early history of the cosmos. We've seen stunning, detailed images of the Carina Nebula and the Pillars of Creation, revealing thousands of newly formed stars that were previously hidden from view. And in the realm of exoplanets, Webb has already made history. It has detected clear evidence of water and carbon dioxide in the atmospheres of several gas giants. These early successes are just a taste of what's to come, paving the way for the eventual search for habitable conditions on Earth-like planets. Every new observation adds another piece to the grand puzzle of the universe. The James Webb Space Telescope is so much more than a piece of scientific hardware. It's a testament to human ingenuity and our unyielding drive to explore. It represents what we can achieve when nations and people from all over the world come together with a common goal: to expand the boundaries of knowledge. For every scientist and engineer who worked on it, and for every person who looks at its images with a sense of wonder, Webb is a symbol of hope and inspiration. Its discoveries will help us answer some of the biggest questions we can ask: how did the first stars ignite? How do galaxies grow and evolve? And ultimately, what is our place in this immense, beautiful, and mysterious universe? For the next generation of scientists, dreamers, and explorers, Webb's legacy will be a foundation upon which to build, a call to keep looking up, to keep asking questions, and to never stop reaching for the stars. The James Webb Space Telescope is a masterpiece. With its giant golden eye and its ability to see in infrared, it's just pulling back the cosmic curtain and showing us a universe more magnificent and complex than we ever imagined. From the first echoes of the Big Bang to the potential for life on worlds beyond our own, Webb is writing a new chapter in the story of humanity's relationship with the cosmos. The journey has just begun, and the greatest discoveries are still ahead of us. Thank you so much for joining me on this cosmic journey today. If you enjoyed this and want to see more about the wonders of our universe, please consider liking this video and subscribing to the channel. It really helps us continue to create content like this. Until next time, keep looking up.